my name's Jack. I'm currently doing research at the Colorado Fuel Cell Center, and my mentor is Neil Sullivan. What I'm working on at the Colorado Fuel Cell Center is a fuel cell. What is a fuel cell? A fuel cell is essentially a fancy battery. A fuel cell operates on hydrogen. There are three parts of a fuel cell. There's an anode, electrolyte, and then there's a cathode. So hydrogen goes through the anode, and then there's also oxygen that runs through the cathode. So the hydrogen that runs through the anode essentially cannot go through a dense electrolyte layer without getting rid of an electron. So the electron goes through this wire. This is where the energy is able to be produced. And then it essentially creates water, and then from the oxygen that is going through the cathode material. So what my lab is specifically working on are proton conducting ceramic fuel cells, which are a version of solid oxide fuel cells. So what is a solid oxide fuel cell? A solid oxide fuel cell is a fuel cell that operates at higher temperatures. So there are some benefits to a fuel cell that operates at higher temperatures, mainly that you do not need pure hydrogen. So you could have natural gas of any sort, and you could just stick that right through the anode, and that would be efficient enough. There wouldn't be any cell poisoning, just because it is operating at that high temperature. So from the solid oxide fuel cell, it is also important to note that another benefit is the cost. So when you're producing pure hydrogen, you have to go through a main process right now called electrolysis, which is very costly. So with a solid oxide fuel cell and just using a natural gas like CH4, you can eliminate that whole process, which makes the whole idea of a fuel cell cheaper. So the difference between a proton conducting ceramic fuel cell and a solid oxide fuel cell is a couple things. So the cost to make a proton conducting ceramic fuel cell is much, much cheaper than a solid oxide fuel cell. The reason for that is the fabrication process. There's only one step in a proton conducting ceramic fuel cell in order to fabricate or to sinter the anode, electrolyte, or cathode, while in a solid oxide fuel cell there are multiple steps in sintering that anode, cathode, or electrolyte layer. So it's just much cheaper just because there's only one step for that fabrication process rather than multiple steps. Also, a proton conducting ceramic fuel cell operates at a lower temperature than that of a solid oxide fuel cell. That could be an advantage, mainly because there's less degradation at lower temperatures, which just increases performance. So mainly what my laboratory is, or what my research is focused on, is a tubular fuel cell. So a tubular fuel cell is the same idea as a planar fuel cell, except it's just formatted a bit different. So you have an anode in the inside, then you have an electrolyte solution sprayed onto that anode, and then you have a cathode solution on the outside. So essentially what's going on is the hydrogen is going through the anode, and then you have oxygen going through the cathode outside layer of the cell. This tubular fuel cell is a good idea versus a planar fuel cell. They have their advantages and disadvantages, but because the cathode layer is a little larger, you can have more oxygen going through the cell at one point. It's a bit more efficient than that of a planar fuel cell, just because of that oxygen going through. So my research specifically is working on the anode. So what my research is looking at is I am making a cell from scratch with multiple different compounds. I am mainly focused on the cornstarch solution within the whole mixture itself. So I am currently doing a test between 30% cornstarch mixture and a 40% cornstarch mixture. So when I'm making this cell, I either do 30% cornstarch or 40% cornstarch, depending on what cell I'm making, and then the whole goal is to test that cell and see what the performance is. So within that process, once we make the anode part of the cell, then an electrolyte solution is then sprayed onto it, and then it's sintered for a little bit, and then for the experiment, we put that guy right into the experiment here. So how this experiment works is this tubular cell up here is cut into some small little pieces where you have a tubular cell right here in the middle, which is pasted on to an inlet and then outlet metal rod machine. So what that does is within the rods, there's hydrogen going through the inlet, and that hydrogen is going all the way through into the tubular cell and out of the tubular cell, and then the H2 goes out the outlet of the machine. Also, there is a bubbling of the H2O, which is essentially making oxygen to go into the cathode, which optimizes the performance. With that, that just gives us a good test and gives us optimal conditions, so we can just test the changes in that cornstarch solution. So how this works is there's some silver wire running out of the tubular fuel cell. That's where you can track all the data. Then we use a spectrometer to get two graphs. One graph is a graph of the power density versus the voltage, and then the other graph is essentially of the ohmic resistance. With that data, we can then calculate and figure out what mass percent or what mixture percent is the best in order for the best optimization of the cell.